Okay, before I introduce him, I wanted to thank several people. Neil Berezin, number one, who met Richard Murphy and did the initial invite for him to come and talk to us today. And then we need to thank Bob Lewis, who always does the work in terms of making sure that the guest's computer is going to work with our system. And then also to Constantine, who takes care of videoing our sessions for us. So anyway, so give those guys a hand. And one of the things that's really important is that each of us, for instance, Neil met Richard in a hot tub at his fitness club. So that's how they got introduced. So you all run into people who might have an interesting subject that might like to talk to us. So keep your eyes open. And if you meet somebody who thinks you might have an interesting subject, let us know. Okay, so just get in touch with myself or Bill Fitzgerald or Andre. So with that, we're going to have Richard Murphy, who is a marine ecologist, and he became associated with Jean-Michel Cousteau and Jacques Cousteau in 1968, and worked with them in a number of capacities, including, I think, photography and many other things. And he's going to talk with us today about coral reefs and sustainability. And we all know how important the coral reefs are, and many of them are really at risk right now with all the changes in the climate and the level of acidity in the ocean. But with that, Richard Murphy.
Okay.
Thank you.
Thank you.
Okay.
Thank you. I was going to stand over here. Can you all hear me, or is it better for me to? By the microphone.
That one right
okay.
there. No, just take it with you. Yeah.
Oh, I see.
It comes right out.
Take it out.
There
okay.
you go.
Thank you. I don't want to block the screen. Can you see the screen just fine? Is this okay?
Yeah, that's it. About 4 or 5 inches from your.
Okay. It's working. Okay. Thank you very much. It's an honor to be here, and I appreciate the opportunity to tell you some stories and share some of the wonder of. Okay, back a little more. There we go. Okay, share the wonder of the ocean that I've experienced with you. Louder.
Don't get out of frame too far because he's videoing.
What do you say? Tell me.
You're stuck with.
Come back.
This way. This way.
This way. Come back in. We want you in the frame.
Okay. Well, then I guess I understand. I'm just okay. Anyway, so we'll get over that. So it was, as you probably know, Jacques Cousteau and his team who really explored the ocean and shared the wonders of it with the public of the world. He co-invented the aqualung, enabling him and his team to swim around like a fish, free from a connection to the surface. And so that really began our deeper understanding of the ocean and appreciation for its value. The questions, of course, they had were like what we had, in a later generation about what's going to happen when you go into space. Well, the question is, what's going to happen if you spend more time underwater? We know about the bends and nitrogen narcosis. How deep can you go and how long can you stay? So created a habitat, a little underwater city in the Red Sea, and it's called Conshelf 1. And they had about 10 guys who lived at 30 feet, and then two other guys went down to 300 feet to test and see could they think, could their physiology work, what would happen to them. So that was really exciting times, and it was National Geographic that became aware of this and did a number of issues and articles on the Cousteau experiments, and that of course gave him the opportunity to He always liked to make, Captain Cousteau liked to make movies, and so with the connection to National Geographic and making one documentary called World Without Sun, maybe some of you saw it when you were very young, really launched Cousteau into exploring and making movies about the environment. And of course, in the beginning, since nobody else had been making movies about the ocean seriously, we did all the easy things. This was my first expedition in the blue hole of Belize. We made movies on, you know, coral reefs and whales and sharks and all of that, the easy stuff. And then with time, we came, as Cousteau would go back to the Mediterranean where he grew up, he would see that his backyard basically was changing, that the fish weren't as big, there weren't as many of them, the waters weren't as healthy as they were, and so he began to become an environmentalist. And he wasn't an environmentalist in the beginning at all. He was just out exploring, making movies and, you know, having a good time. And but with that perspective of history, because he was really a snorkel diver for a long time before he had the aqualung, and then looking at his backyard, seeing changes, he said, whoa, man, things are not good here. And of course, as the team, he and all the rest of us were going around the world talking to fishermen, talking to people responsible for the environment. This is back in the 60s and 70s. The story became pretty consistent. Yeah, the ocean just isn't as healthy as it used to be. It's not producing as much as it used to. And so, oh my goodness. Hang on. Okay, and so it was in the early 80s when our team, I began with him in 1968. So we thought, you know, rivers are the roots of the sea. And everything that we do on land, more or less, is going to end up in the sea. You know, the drainage, the sewage, the rivers, the streams. And so we thought, well, then let's make a movie about the rivers and show the connections between the ocean and the land thanks to the rivers. So we went to the Amazon, and we got Ted Turner to give us a guarantee to support us for 4 one-hour documentaries. This is back in '82 that Calypso came from the Atlantic up into the Amazon basin, and then Jean-Michel and I, Jean-Michel's on the left, I had hair on the right those days, and we went up to the top of the mountain that's the source of the Amazon, called Mount Mismi. It was 18,300 feet. You know, and here we are, ocean guys, climbing up to that altitude, which is a real challenge. We'd walk for 5 minutes and just sit for 10 minutes gasping. But we had the helicopter organized so that when we got to the top of the mountain, then the movie could begin from that point of view. And of course, Cousteau being Cousteau, he got to throw his snowball east, and of course that would go 4,000 miles down the Amazon into the Atlantic. I'm just a Murphy, and so I threw my snowball west, and it went about 200 miles to get to the Pacific eventually. So anyway, we then followed that river, the land team, which was us starting on the mountain, down into the Amazon basin, and it was quite a journey. You can see it's not a straight shot, but it was just fascinating. And thanks to our having a helicopter, we were able to go up and look around and see where we were and what might be going on. And one of the things that we discovered was, I'm just sorry about that, was an area maybe 3 times the size of this room in a little bay that had a narrow entrance, and there was a dolphin in there. I go, wow, that's cool. So we put a little net across this entrance. We were working with people in Brazil who were studying marine mammals. We had a seaplane, so we went and flew them in, and they stayed for a day, and we did the studies on the dolphin. But they weren't divers. They had no history going in the water, because generally the visibility in the Amazon is 0. But in some of these little offshoots and oxbow lakes, the water was more clear. And so after that, and I was the still photographer on this part of the expedition, and so I thought, wow, this is cool. We have a completely wild, captive dolphin. I'm just going to go out there and spend some time with it and just kind of hang out, and I'll try to take a couple of pictures. And so I had a weight belt. The water was probably only 10 feet deep, and the dolphin would come up to breathe, and then I'd come up to breathe, and I'd just sit on the bottom, and the dolphin was resting on the bottom. Well, after a day of this, then, of course, I went to sleep on the beach, came back the next day, and as the dolphin would come up to breathe, then I put my hand up once just to kind of touch the dolphin to see what was happening. And it didn't freak out, it didn't bite me, it just kind of shivered. So I come up for my breath of air, I'm down on the bottom, dolphin goes up for its breath of air, comes by, and I put my hand up, and it stops. It just hovered. You know, they're very tactile, and so apparently to me, it wanted to be scratched. I go, this is weird, okay, fine. And so now I'm lying on my back, scratching this wild dolphin, and so that went on for a few breaths of air. And one time it came down and just sort of rested on me like, okay, let's, I like the scratching and the tactile experience, and keep going. I go, oh, this is great. And I had a couple little kids, so I thought, well, here the dolphin's upside down. And I'm not in charge at all. And so it's just rolled over, saying, okay, scratch me. So I get the camera and put my left arm around the dolphin, and then my right arm with my wide-angle lens to take a picture for my kids. But so the message to me was, if we're gentle and respectful with nature, we will be given all kinds of wonderful opportunities to interact, to learn, and to just have a pretty profound experience with some of these otherwise wild animals. Okay, so as time went on, this was in the early mid-'80s. We were in the Amazon for 2 years off and on, from 1982 to 83. And the question then was, Calypso's an old ship. It was built in 1942. It was a minesweeper, and it just wasn't real high-tech. And we wanted a new ship to replace it, and we wanted it to be environmentally responsible. And so we found a guy getting his PhD in Paris on fluid and aerodynamics. And our question was, how can we have an environmentally responsible way of capturing the wind that would help us power the boat? And so these things are called turbo sails, and they are hollow on the inside, a fan at the top, and they pull, they act like the wing of an airplane. Okay, so the wing of an airplane, air goes over the top, there's less pressure at the top, more underneath, and so you get lift. If you take that wing and orient it vertically, as the wind blows around this thing, then you will get some thrust. The problem is, with a great degree of curvature, you have turbulence on the downwind side. Well, by having these little holes along the side, you can suck in a little bit of air, prevent turbulence, and by pulling the air up and out of the top, you can get 7 times the thrust per unit area as would a fabric sail on a sailboat. So that was quite an interesting invention. The Cousteaus never were able to build Calypso 2, but at least this technology we were responsible for creating, and it was out there in the marketplace, and another option for environmental responsibility and reducing the use of energy for ships. Okay, so by the mid-'80s, we had a lot of toys. And we had the Calypso, we had Alcyon, the wind ship, we had a seaplane, helicopter, submarine, and we were making 4 one-hour documentaries. And those were exciting times. I'm sure many of you saw those films that we made. And what did we learn? Well, by then we did have pictures of the blue planet, the blue jewel, the oasis in space. We live on a water planet, bathed in 2 fluids. One fluid is the atmosphere, the other is the ocean. And those two fluids are constantly in motion. They're exchanging everything, and they're moving whatever we put into those two environments all over the world. You can't throw something away. There is no away on planet Earth. And so this image was was important for us as we were thinking about pollution, the environment, and the interconnectedness of everything on the planet. And of course, it's water that keeps this planet habitable. It's water that keeps us habitable. We're 66% water. And of course, water is quite special. It resists freezing. It resists turning into a vapor, boiling. More different substances dissolve in water than anything else. So it's quite a special substance. And when we think about the life, what is life? It's water alive. I mean, this planktonic gelatinous comb jelly is probably 98% water. So it's just water that's organized by membranes where chemical processes take place along those membranes, and it's alive. And we're, again, mostly water. Those same processes are taking place in us. And we think about that concept of interconnectedness. The genetic alphabet and the genetic code of all living things are the same. Whether it's a bacterium, a worm, a lion, or us, the language and the alphabet are the same. And of course, and we learned about those basic chemical processes from bacteria. The physiological processes that keep us alive are the same in all organisms, even plants. So we're really, our differences are a question of packaging, not substance. We are all really related. We have a common evolutionary past, and we certainly have a common future as humans affect the planet. So understanding those So understanding those basic processes have helped us develop various educational programs for people to try to get people to appreciate the fact that whether it's a diver, a fish, or a coral, we have more in common than we are different. And if we could feel deeply the connections that we have to other living things, our planet would be better and our future would certainly be better. And because we are really all brothers and sisters and cousins and aunts and uncles. Okay? So as we look at corals, you think, yeah, cool. Corals are kind of fun. They're animals, of course, but look at the form of that coral. Isn't that weird? It looks like it's a plant. It's reaching up towards the surface. Well, this is the building of the city under the sea. And these buildings are alive, and they're made by animals. And of course, those buildings are home, just as in our cities, to a whole bunch of different creatures. And you think about all of you and all of us, we had different careers, we're very good at different things, and collectively, we're all necessary to keep our societies and cities going sustainably into the future. And so it is with the coral reef. The buildings are alive, and all of these different species have jobs, and the work they do is very critical. Even things we can't eat and sell have value because they're doing important work, okay? So now if we look at this city under the sea and its diversity of residents, we think about, well, wait a minute. The corals are animals, and it turns out that the tissue of a coral is transparent. It doesn't have any pigment. Oh, they're all green and brown. What's that? Oh, there are algae living inside the coral. Microscopic plants that are catching sunlight, making food, paying rent, leaking out amino acids and carbohydrates to the coral. And the coral's going, great, I just got a meal. And that explains why that coral is reaching up for the surface. It wants to keep its rooftop garden producing food to keep the coral alive. And look at this brain coral. You think about, well, they're certainly not doing a lot of thinking. Well, why do we have all those meanders in our brains? for more cells, or brain cells, to do more thinking. In this case, it's more cells of algae to make more food to keep the coral going. So now we see that there is, and the waste of the animal is the fertilizer for the plant. So now our city has rooftop gardens where, in a sense, if the toilet is flushed, great. All those nutrients go up to the surface to keep the algae and the gardens happy. And this system, this physical system, provides home and an opportunity for a whole bunch of different creatures to do their jobs. And in addition, where there isn't real coral alive, like the bottom here, there is algae growing on the bottom. So pretty much this city has photocollectors everywhere. Almost every surface is collecting sunlight and making food. You look at those scrape marks. Anybody have any idea who might have made those scrape marks?
Parrotfish.
Parrotfish, absolutely. Okay, whoops, going the wrong way. Okay, and look at the beak. You can say, oh, that's why they're called parrotfish. They're going around scraping off the algae from the bottom. And in the process, as you saw, they're excavating a little bit of the limestone, and they poop sand. Go, well, what do you think about that? Well, a parrotfish this big can produce 200 pounds of sand a year. And a population of parrotfish on a reef produce tons of sand. And that, of course, is a habitat for other things to live. And even when you and your sweetie go walking along a beach, you can remind her that some of the sand of that beach has gone through the digestive tract of a parrotfish, okay? And it's not only parrotfish that are the, quote, grazers cleaning the bottom of algae. You know, if you have a garden, you don't want the weeds to overgrow your plants. Well, corals don't grow as fast as some algae. So it's important to have these herbivores, these lawnmowers, going along the reef, keeping the surface, quote, clean, so that new corals, the babies, the larvae, can settle and form more corals. So there's this dynamic equilibrium of the erosion of the reef by these herbivores, and then, of course, the rebuilding of the reef by the corals. Okay? And there are managers in this system. Okay, what's a manager? Well, a manager is, there aren't very many managers, but they do important work because they have the ability to control the system. Okay, so whether it's an eel, a grouper, or a shark, these high trophic level predators are very important and very valuable for maintaining balance on the reef. And in some areas where people have caught all the sharks, they find that the ecosystem is out of balance and the coral reef isn't nearly as healthy. And so it's important, in other words, it's important to have these predators, these big predators on the reefs to do important work that they do. And of course, there's the garbage collectors. You know, if you don't have somebody cleaning up all the waste, your city, your community will become a bit of a mess. And of course, that organic matter is something that's a valuable resource, and so it gets recycled by these sea cucumbers. And you can see the poop of the sea cucumber here is cleaner than what it was eating because it's digesting the organic matter. So we even have recycling and the health of the system being maintained by these worms, shrimp, and sea cucumbers. And when we think about recycling, the supreme recycler, of course, is a hermit crab. That shell on the left is a murex snail, and the snail died, its shell is left over. Then the hermit crab comes and, whoa, this is a free mobile home. And so even an empty shell isn't a wasted shell. It's a very valuable resource for the hermit crabs. And then in terms of air conditioning, what we have here, well, the sponges are sort of the air conditioners or the water conditioners of the reef. They're pulling water. Sponges don't move. You know, once they're attached to the bottom, that's it. But so they pull the water through their bodies and then filter it in the process. And because they have sometimes toxic or distasteful chemicals, they're not eaten, and the work that they're providing, of course, again, is the important function of all the diversity of species for the reef system. And when you get sick, what do? You go to the doctor. And the doctor, and how do you know who the doctor is? Well, you go to the doctor's office, and then the man or woman comes out and they have their doctor stuff on. Go, oh, that's the doctor. Well, that little blue and black fish is the doctor. And a number of different species have the same coloration that identifies them as the doctor. And the fish come to that cleaning station where then their parasites are picked off. Well, that's a pretty good deal. If you go to the doctor and the doctor doesn't charge for his or her services, instead they say, oh, well, thanks for all those scabs and tumors and all the rest of the stuff I'm taking from you. And you go, thanks, I feel better. And the doctor says, free meal for me. And so those cleaners are very important. Again, there have been scientists who remove the cleaners from a section of reef, and they found that the abundance and diversity of other fish goes down because they've gone somewhere else. A lot of these fish go to sleep on the bottom. You know, they just at nighttime, they go down the bottom and just, okay, well, that's fine. And there are parasites that live on the bottom, little crustaceans and things, and so they crawl up on the fish. So in the morning you wake up and go, oh my gosh, I got a problem here. So you go to the doctor. And these doctors, when I go out to do my photography, I look for a cleaning station, because that's where I will find an aggregation of different species of fish, and they're all kind of hanging out, waiting in line for the doctor to do their services. Okay? Oh, man. Okay, and in terms of living symbiosis, mutualism, organisms living together. You got the cleaners and all the rest of the fish benefit. Each benefits the other. You have the corals and the algae. Each benefits the other. And of course the clownfish living in the sea anemones. Well, sea anemones have stinging tentacles. Well, the clownfish have a mucus that prevents those stingers from discharging. So we see integration, collaboration, mutualism at the species level, and then at the level of the whole ecosystem. Oh man, I wanted to go back, but anyway. So you get the message about a very complex, integrated ecosystem where there is balance, there is productivity, and they're sustainable. That's the big lesson. Here is a brain coral. Notice its color, normal like I mentioned because of the algae. When the water temperature, thanks to climate change, increases, the relationship between the coral and the algae break down. The algae are kicked out and the coral turns white. It's called coral bleaching. And that's a big deal. It's becoming a bigger problem on a global scale. You probably read about the Great Barrier Reef and coral bleaching. The Caribbean coral reefs are nothing like what they were when we were all young, because there's been bleaching and a whole bunch of other factors that have affected the health of those reefs. And that's what, of course, a normal coral looks like. And, of course, it has a community of creatures around it. And this, it's interesting. And this is what many corals look like in the Caribbean and around the world. The coral animal has died. There's nothing around it, and it's overgrown with algae. So we really see that there's a lesson from this perspective of a coral reef being a city under the sea. By having rooftop gardens, by recycling, by valuing biodiversity, and understanding everything is connected as it is on these reefs, we find that these reefs are sustainable. A human community, civilization, 3,000 or 4,000 years, and most of us crash because we've screwed up. Whereas these reefs continue for millions of years. So there are really some lessons from the wisdom of the reef that I think we should pay attention to and can give us a little bit of inspiration and guidance as we look to the future. Let's see what else. And those processes I'm talking about a living building and a whole bunch of species, are exactly the same in rainforests. In fact, all natural ecosystems that are complex have those same principles that apply to them and keep them running smoothly into the future. And so our latest, with Jean-Michel Cousteau, our latest project has been, we finished 4 years ago, making a 3D IMAX movie. And that was really, really exciting because we went back to a number of places where we've been, where of course the reefs are healthy, and then made a film about that. And our ability in this, with these new cameras that we had, we could fill the screen with something this wide. Okay, so you think about, if I take a picture of this cup, you go, well, it's okay, so what? Well, if it's a weird creature and it's blown up on 100-foot wide screen, go, whoa, you know, when you look at things really closely, sometimes they're just bizarre and they're really interesting. So we offered a new perspective through this movie that we made. So I'll end on that, and so that was our latest big project. We have a number of educational programs around the world with hotels and various groups, but I'll stop at that, and if any of you have any comments or questions, I'll be happy to entertain them. Okay?
Okay. Neil, we're gonna pass the mic around when you have a question,
And then you can.
and I'm gonna interpret.
I have one to start with. Microplastics that are just invading the entire ocean. Are they a big factor in the killing of these reefs?
I'm sorry, with my ears,
He's asking about
I
the,
spent a bunch of time underwater in cold water, and my ears are screwed up, and the acoustics in here are a problem.
yeah, he's asking about like the microplastics that are, you know, you see them from cigarettes and all sorts of things in,
From our perspective.
how are they affecting the reefs?
From our perspective, the microplastics are a gigantic issue because, as you can imagine, a plastic bag, say, goes into the environment and the waves break it up and the sunlight breaks it down. The plastic doesn't really disappear. It just breaks down into smaller and smaller particles. And the smaller the particle, the more easily it might be ingested by plankton. And then, of course, the little fish eat the plankton, and the bigger fish eat those, and bigger fish and bigger fish. And those plastics not only are harmful in themselves, but those plastics, but other chemicals attach to those plastics, so they can become even more toxic than they would have been by themselves. And then these are staying in the food chain. They're now in the Antarctic, they're at the bottom of the deep sea, and they are everywhere. And they're coming back to us in some cases in the food we eat. You know, if we eat anything that isn't mussel, like an oyster or clams and stuff like that, you're eating the whole organism. Well, those organisms are going to be accumulating some of those pollutants, particularly the plastic. So we really need to be working to reduce our use of plastics and create other molecules, other substances that break down into benign products rather than maintaining themselves as plastics that will last for thousands of years. Okay, good question.
Okay, Richard, these microplastics, we're hearing about them now because we're seeing ads on TV and all that. How long have we kind of known about this problem? Because to me, you know, I think I look into a lot of things and I was not aware of it.
There was a guy at Woods Hole, I think it was in the 80s, and he got his PhD looking at those microparticles that are accumulating in the food web. And of course, it takes a while for, you know, the coral bleaching. It was known. I'm sorry, ocean acidification. Nobody thought about that until about 20 years ago, and now it's become a big deal. And what I mean when I say that is, as carbon dioxide dissolves in the water, it forms carbonic acid. And you go, yeah, so what? It's not that acid. No, it isn't very strong acid, except calcium carbonate easily dissolves in a weak acid. Oh, well, wait a minute. Coral skeletons are made out of calcium carbonate. There's coralline algae everywhere. The shells of snails and clams, they are the skeleton of crustaceans. The bones of organisms, they are all involving calcium carbonate. And so making that calcium carbonate more easily to dissolving and more difficult to make as these organisms are making their shells is really a big deal. And some people, or some of the scientists, are saying, now coral bleaching is not the big one. The real big one is ocean acidification, because anyway, that can be a real big one. We don't want to go too long on that.
Okay.
Another one.
Next question. Okay. Neil.
Just a comment.
It's on. It's on. Just bring it closer to you.
Yeah, it was the biggest landfill in the world is the ocean.
The biggest landfill in the world is the ocean.
Absolutely, absolutely, and you can't. We used to talk about it as the universal sewer.
Yeah.
Everything's coming off the land, and where's it going to end up? Jacques Cousteau, and I think it was in 1956, when nuclear power was being just developed in France, and the awareness of pollution and consequences in the ocean was pretty much zero. He got, because he was an ocean guy and a diver, he said, no, there were train loads of radioactive waste being shipped to the Mediterranean, and they were just going to be dumped in the Mediterranean. He said, no, you can't do that. And the scientific community, of course, politics, and the nuclear industry say, that's an environmental tree hugger, forget him. Well, what he did is he got a bunch of mothers in 1956 to sit on the railroad tracks in France to prevent the trains from dumping nuclear waste in the Mediterranean. And of course, he was proven absolutely correct about the toxicity and the longevity of some of these wastes. And and eventually there's a museum in Monaco, and that is the center of standards for European pollution studies. And eventually he became the director of the museum in Monaco. And we still go to them for the quote, certification of standards for pollution. But Cousteau has a very long history in that, and he wasn't an environmentalist in the beginning. It was his experience and observation traveling the world and talking to people that convinced him that all these environmental subjects really are important. Okay.
Richard, what can we do to help this? What can we specifically do?
Do two things. Every time you go to the store, you're making a decision. Are you buying organic food? Are you getting sustainably caught seafood? Are you voting? How are you voting? Well, those are all decisions, and so in my opinion, there are two levels. There's the level of your own personal behavior, what are you buying or not buying, and we know that the market has power. Think about in your lives how organic food in the beginning was well now, thanks to the purchasing power of the public who cared, we now find organic food everywhere, and it's becoming much less expensive, and we know it's much more environmentally responsible. Our internal environment, our bodies, and our external environment that we live in. Both of those two environments are very sensitive to pesticides and toxic chemicals, all the stuff we know about. But so our own purchasing power is very, very effective, and as we vote, we are making decisions. Do you care about climate change or not? Well, that's a personal decision. But for those of us who, in our case, have grandkids, I am concerned about the environment. I'm sometimes thinking, man, I'm glad I'm not just a little kid, because that kid's future is going to be very different from the future that all of us had in terms of the abundance and health of natural resources out there, and opportunities to play and have fun. Okay.
Another question out there? Neil, can you get a mic to him besides just sitting there, Neil? Thank you.
One question, yeah.
A few months ago, Dr. Drake was here talking about water supply on the land, and he talked about a lot of things, but one of the things desalinization and some of the arguments against desalinization. And one of the arguments was that by desalinizing the seawater, and we would be putting a lot of salt back into the ocean, and that would be harmful. What do you think about that?
Okay. He's asking about desalination and putting the salt back into the ocean. What impact is that going to have? So you're running a desalination plant, and then you got the salt, and it goes back into the ocean.
That's a complicated one, because as we drain the Colorado River and affect not only the river itself, but the populations of fish and other creatures in the upper Gulf of California, there's just not enough water for everybody. The ocean's full of water. So then the question is, if we're going to get fresh water out of seawater, where do we put that brine solution, and how do we put it back? Certainly the capacity of the ocean to assimilate a little bit more salty water is great, but because of economics and logistics, we say, well, let's just put it over there and forget it. Well, over there is close to shore. Over there is not 10 miles out into the ocean. It's where the highest productivity in the ocean are along the coastlines. Well, that's the worst place that we should be putting back that salty water. And of course, we're bringing in salt water full of plankton, larvae, baby fish, all kinds of other organisms that are going to be killed in that process. So obviously conservation and recycling is by far the best way to go. Desalinization in some cases is almost a necessity depending on where people are. But as you mentioned, the consequences are serious and they need to be thought through. And in some cases, it's a question of, well, we want to do it as cheaply possible. We don't have a budget to really deal with the environmental issues, and that's wrong. That we should be thinking about the direct and indirect externalities. The direct cost is how much it costs to build it. The externalities are, what are the consequences of the larger scale that are difficult to quantify? But we need to spend the money to do it properly when it's absolutely necessary. I feel that conservation, recycling, in the space station, they're drinking pee. Well, we should all be drinking pee, but pee that's been processed and treated and recycled for landscapes and all that. So that whole water issue is complex, and I think there are good examples and good opportunities for doing the right thing. So I'm not an expert in desalinization, and so that's my answer.
Okay. Any other questions? One more, and that's it.
Okay, maybe we're out of time.
One more. Thank you, Neil. Talk into it.
Are there sharks and whales in the Mediterranean?
Are there sharks and whales in the Mediterranean?
Oh yeah, absolutely. Yeah, there are lots of sharks and whales in the Mediterranean.
Is the water really as blue as they show it in like the Hotel Portofino? Have you seen that? Is it?
Some of it is.
Okay.
Well,
That's what it's
blue, the color of water is a reflection of what's in it. The less stuff that's in the water, the bluer it is.
Oh.
Along coastlines, it's either generally brown or green. Well, the brown could be sediments, or it could be red tides. It could be plankton. Green is plankton. Well, that isn't necessarily bad. It's a question, like everything, of carrying capacity. How much nutrients are being put into the coastal waters, and are they, along here, upsetting the natural balance, stimulating the bloom of toxic algae that can then affect bivalves and shellfish, and that's bad. So you think about coral reefs live in clear blue water. Oh, that's just wonderful. But let's fertilize the sea, and we'll make everything rich. Not on a coral reef. All you saw the connections with the algae, and all these things are very finely balanced. When you add when you add nutrients to a coral reef, you don't make a coral reef happy. You really screw it up. It's like adding water to a desert. Do you make the desert happy? No, you change it into a different ecosystem. So, add fertilizer to a coral reef, well, you'll probably kill the corals and the ecology. There will be things growing there. There'll be lots of algae, but it's not what we would call a coral reef. So on the clear water and nutrient story, it depends on where you are. And why do the whales migrate to the Arctic? Because there's nutrients up there and a lot of sunlight. And those nutrients in that case are really, really good. That keeps the productivity of the system going. And adding nutrients to the tropical waters that are generally depleted in nutrients isn't good at all. Nutrients are valuable. We should keep them on land and use them to stimulate our own agriculture. Okay, I think we've probably reached our limit.
Yeah.
Anyway, thank you. It's
All right.
nice talking to you.
Thank you so much. Thank you, Richard.
We appreciate that urgent letter.